need to pass optional configuration to your FastMCP resources without cluttering your URI paths or writing separate endpoints for every variation. You'll see how to use RFC 6570 query parameters to expose flexible, configurable resources that clients can customize on demand. We'll implement 3 practical examples: format switching for data responses, pagination controls for API calls, and file reading with customizable encoding and line limits, all through clean URI templates that separate required path parameters from optional query settings. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals data server. Hash basic query parameters. At MCP resource, data//id format. Def get data ID. SDR format, SDR equals JSON SDR. Retrieve data in specified format. If format equals XML. Return F data ID equals ID. / Return F ID. id. Hash multiple query parameters with type coercion. At MCP resource, API//endpoint version limit offset. Def call API endpoint. SDR version, int equals 1 limit, int equals 10 offset, int equals 0 dict. Call API endpoint with pagination. Return. Endpoint. Version. Limit. Offset. Results. Fetch results endpoint version limit offset. Hash query parameters with wildcards. At MCP resource, files //path asterisk encoding, lines. Def read file path, SDR encoding. SDR equals UTF-8 lines, int equals 100 SDR. Read file with optional encoding and line limit. Return read file content, path, encoding lines. This demonstrates the URI template pattern for creating parameterized resource endpoints. The approach uses RFC 6570 URI templates to define dynamic resource paths, where placeholders in the URI map directly to function parameters, enabling clean separation between interface definition and implementation logic. The pattern works by treating URIs as declarative contracts. Path segments and query parameters become function arguments automatically, with type hints driving validation and coercion. This creates a self-documenting system where the URI structure itself describes the available parameters, their types, and whether they're required or optional. This approach solves the problem of exposing structured data access without hard-coding endpoints. It's particularly valuable for APIs, file systems, or any scenario where you need to expose hierarchical data through predictable, parameterized paths. The trade-off is slightly more complex URI design upfront, but it eliminates the need to register individual endpoints for every possible parameter combination. Let's break it down. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI callable tools. It transforms Python functions into structured endpoints that AI models can query, handling serialization and type coercion automatically. MCP equals FastMCP. Name equals data server. This initializes the FastMCP server instance named data server. This central object routes all AI callable tool requests, acting as the entry point for the entire API. The name parameter identifies this server in logs and monitoring, enabling traceability across distributed calls. Without this instance, no endpoints would be exposed to AI models. Hash basic query parameters. At MCP resource, data//id format. Def get data ID. SDR format, SDR equals JSON SDR. Retrieve data in specified format.
If format equals XML, return F data ID equals ID, / return F ID, id.
This defines a FastMCP resource with a dynamic root and optional query parameter. The id path parameter captures a required identifier, while format makes the format optional with JSON as default. The function demonstrates content negotiation by returning either XML or JSON based on the format parameter.
At MCP resource, API / endpoint version limit offset. Def call API endpoint, SDR version, int equals 1 limit, int equals 10 offset, int equals 0 dict. Call API endpoint with pagination. Return. Endpoint. Version. Limit. Offset. Results. Fetch results endpoint version limit offset.
This demonstrates FastMCP's multi-query parameter handling with type coercion. The URL template, version limit offset, automatically parses and converts query parameters to their declared types, int for version limit offset, while the endpoint path variable remains a string. This pattern enables clean pagination support in API calls, with sensible defaults preventing missing parameter errors.
Hash query parameters with wildcards. At MCP resource, files / path asterisk encoding, lines. Def read file path, SDR encoding. SDR equals UTF-8 lines, int equals 100 SDR. Read file with optional encoding and line limit. Return read file content, path, encoding lines.
This demonstrates FastMCP's wildcard path matching with optional query parameters. The path captures multi-segment paths like doc/2024/report, txt as a single string, while encoding lines makes file reading parameters optional with defaults. This pattern handles flexible file system navigation while maintaining clean parameter defaults. FastMCP URI template pattern. The URI template system bridges Python function signatures with network-accessible resources, where path segments become required parameters and query strings expose optional overrides. Query parameters automatically coerce string inputs to Python types based on your function's type hints. But this magic fails silently if the client provides malformed values. Design your templates so the URI structure itself documents the API contract, making optional parameters visible in the path when they should be client configurable.
The resource that hardcodes its path becomes invisible to those who need to find it.